Hello everybody, it's Mr. Joseph. Today I'm going to talk about different forms of quadratic functions. But before we do that, we're going to talk about this box real quick that kind of shows the distributive property in a different way. So as you recall, like whenever we find the area of a square or a rectangle, which we can never be sure like what the shape is unless we actually find out the values. We know that we take the length and we multiply it by the width. So when I look at this problem here, and just keep in mind that I am only looking at this first box. All I know is these two, this, times whatever number this is, must give me x cubed. So that gives me no choice but to write an x here. So that yellow line that I'm showing you has to be x. And if that is x and that is x, that also means that this is x as well, because the lengths are the same. But the same cannot be said for this part right here, the width, because if you see it, the green times the yellow is going to give me, this time, 2x. So the green times the yellow is going to give me this right here. So I know that my length is x, so that has to make this 2. So if you look at each square individually, you kind of see what they have in common, which was the yellow line. But what is different is their widths. And so as we keep this going, I'm going to also make this green, and I'm also going to make this purple. And now the lengths that go up and down are not the same, actually, because this time we have a 3. So these are the same. So those are 3s, but the purple is still x squared. So it's going to be 3 times x squared, which is going to be 3x squared. And then it's going to be 3 times 2, which is 6. So if you're kind of following, you see the yellow lines are the same, the gray lines are the same, the purple lines are the same, the green lines are the same, which kind of makes sense, like when you actually think about the information that they gave you. So the question I have here for y'all is, what expression could I write to express what's going on here? I mean, the first thing I would write is I would write x cubed plus 3x squared plus 2x plus 6. To me, that would be the more obvious one, because you are adding up each individual area to give you the total area. So the 4 squares equal the big squares. And if you just add each mini area that you found, it gives you this answer. And remember, this is called standard form, even though this is not necessarily quadratic because of this power of 3. So another thing that you could notice is if you take the first two terms, just x squared plus 2, and you multiply it by x plus 3, that this result right here is going to be the same thing as this. And if you don't believe me, let's just do the math real quick. So we're going to take x squared and multiply it by our first two terms. So x squared times x is x cubed. X squared times 3 is 3x squared. Then we're going to take our second term, which is 2, and multiply each term as well. So we get plus 2x, and 2 times 3, you get plus 6, which is the same thing. So these two are equivalent expressions, just in different forms, and we call this form factored form. So it's kind of a cool thing. It shows you distributive property, it shows you using actual shapes to represent, these quadratics or polynomials. We normally just always give equations, and now we kind of have a picture to kind of represent what's going on. So as I scroll down, I'm going to move on to the lesson, which today we were talking about factored form. So factored form is when you're given a quadratic with factors. So I'm just going to write down the general formula for that, which is a times x minus m times x minus n. where m and n are real numbers. So normally you're used to seeing ax squared plus bx plus c. This is called standard form. This is what you're used to seeing. But today we'll be focusing on factored form. So I just want to give you a recap of like what standard form is and how this, we could take this and go this way, and we could also go the other way. But right now we know how to go from factored form to standard form, but we might not know how to go from standard form to factored form. So you'll also learn that soon. So all you do to find the x-intercepts is to take each individual factor. So in this case, I got x minus m. I'm going to set that equal to 0. And then I'm going to take x minus n, and I'm going to set that equal to 0. So you just solve each equation, and it will give you each x-intercept. So I know it's weird here to think about this as m comma 0 and n comma 0, but remember, we're just having variables just to make it general, right? These are the general ways to do this problem. Also, I had a student ask me in class, which was actually a good problem, does it always have to be x minus m? Does it always have to be x minus n? And the answer to that is no. It could easily be x minus m equals 0, so that would cause x plus m equals 0. And if you did solve this, this would give you negative m, so your answer would be negative m comma 0. So just remember, when we write x minus m and x minus n, the m and n could be negative answers and make the inside portion positive. So once again, there's nothing ever better than doing an actual example with numbers, because right now it's kind of abstract, general. So we're going to actually get to an example so you can actually see it at work. I'm going to erase this. Let's get the big eraser. Bam. All right. So when I look at this first question, example 1, I first ask myself what kind of form. This is in factored form. And the reason why I know that is because these are called factors. So you take each factor and you set it equal to 0. And then you solve them. Here, all you do is add 4, x equals 4. So you're going to get to 0.4 comma 0. The one that we normally mess up on or have some issues with is this one. But you just have to remember how to solve a normal equation. Get the numbers on one side, which is negative 11, and then divide by 2. I mean, you could write negative 5.5, but for me, I'm just going to write negative 11 over 2 comma 0. So these two are our x-intercepts, and that's how you find it when it's in factored form. I hope you noticed that these signs did end up being the opposite sign. Like this started off as negative and the answer became positive. This was positive and ended up negative. Once again, it's not a trick or something you have to remember. It's just, the math. Like you make observations when you do these type of problems over and over again. So that's how you go from factored form to find the x-intercepts. So the next part I'm going to do is I'm going to do example 2. So erase this once again. Okay, so number 2, this time I'm given x-intercepts and asked to go backwards. So I know my answer is going to be y equals a, because I don't know what my a value is, and the question doesn't ask to find a. So in order to get negative 3, I know it has to be x plus 3 equals 0, because this is the only way that I can get a negative 3. So that's why it has to be the opposite sign here. And the same thing is true with x minus a half. Because if you took x minus a half equals 0 and you add a half to each side, you'll see that you do get a half. And so this is our answer for example 2, which is pretty nice, right? I mean, it makes sense that the signs should be the opposite, because when you do set them equal to 0, that the signs would change. So the next big question is, here we go, is we have two functions. We we have x squared minus 6x plus 5, and we have x minus 5 times x minus 1. So what are some easy key features I can get before actually doing the problem? So whenever it's ax squared plus bx plus c, you should recall that the c value was our y-intercept, because our y-intercept is our y value whenever we plug 0. And if we plug in 0 to x squared minus 6x plus 5, it's always going to give us our last number. So for here, I can just look at the problem and just say, bam, 0, 5 is my y-intercept. Next thing I should notice is my vertex. Okay, how do I find my vertex? Well, to find my x-coordinate is negative b over 2a, which equals negative 6 over 2 times 1, which is 6 over 2, which is 3. So just recall in the formula that there's already a negative sign, and then in my equation is negative 6. So the two negatives here actually will make it positive, and we get an x-coordinate of 3. So remember, x-coordinate of the 3. So that means I still need to take my 3 and do f of 3 and substitute it into my function. I don't know if you noticed by now, I just like to write everywhere. Sorry if that gives you some trouble following. And I get negative 4. So I know I have my y-intercept, which is 0, 5. And I got my vertex, which is 3, negative 4. It's kind of recommended that you write your vertex in the middle so you can kind of pick points to the left and to the right of it. And that is what I get. So just to label this real quick, y-intercept, vertex. So we'll just stop there for now, because the question really was just asking, like, what are some values that you can find by looking at it in this form? And as you can see, we're able to find our y-intercept, our vertex, and now we can just plug in some random x values to find the rest of it. So I'm not as concerned with that right now. So I'm going to erase this, and I'm going to do the next one. And the next one is g of x equals x minus 5, x minus 1. You should notice this is in factored form, so we can take each of our factor and set it equal to 0. This will automatically give us our x-intercepts in one step. And if you remember doing it in standard form, we actually weren't able to find our x-intercepts yet. So that was just something interesting that you should have noticed, that when it was in standard form, we don't know yet how to find the x-intercepts. But when it's in factored form, we can find the x-intercepts right away, which is nice. So we got x equals 5 and x equals 1. And remember, for your x-intercepts, your value of y is 0. So now I found my x-intercepts. What else could I find? Well, you could find your y-intercept if you understand that your y-intercept is when you plug in 0 for x. So that's why it's really important that you have this flexible thinking and understand what these terms mean, because how to find them will be different in problems, but it still means the same thing. So here I'm going to get negative 5 times negative 1, which is 5. So that means I have the point 0, 5. So by looking at this right now, I was able to find my x-intercepts. And pretty easily find my y-intercept. So now the question is, can we find anything else? So I kind of want to show you something. If I plot 1, 0 and 5, 0, that is my x-intercepts. And if you remember from the last lesson, our axis of symmetry happens halfway always in between our two x-intercepts. So here we know that our vertex actually happens at 3. We didn't even have to use a formula to find that, because we just know it happens halfway. So all I have to do now is substitute 3, and you get negative 2 times 2, which is negative 4. And at this point, I hope you notice that both of these are actually equivalent. That x squared minus 6x plus 5 is equal to x minus 5, x minus 1. Both of them are the same graph, but they just give you different information and different ways to find them. So, and then let's see, it's not 3, 4, sorry, it's 3, negative 4. So 1, 2, 3, 4, so that's right here. 1, 2, 3, 4, 5. So we know our graph looks like that, and that's going to be the same graph over here. So this kind of tells you a little bit about the two different forms and the advantages, disadvantages, what you can find, what you cannot find. So I hope that helps.